Alright, let's solve the system of linear equations by matrices or Cramer's rule. So, let's start with our matrices method. If we're trying to solve our system of equations, first we have to convert it into a matrix. So we have 3, 5, 59, -2, 2, and -2. And remember, when you're using the matrices method, you have to use Gaussian elimination process, which means through matrices operation, we eventually want our diagonal to be 1 and everything below to be 0. Your steps might be a little bit different. There is no right way as long as you end up with the correct answer and as long as you apply the steps correctly. So, when we're doing Gaussian elimination process, we first start with our first value here, and we want this to be a 1. Here, you see here how row 2, so this is row 1 and this is row 2. I see the row 2 is all 2's, so I can easily get them to become 1. I can easily get this one to become 1 by multiplying by -1/2. Into row 2. So that means I'm leaving row 1 alone for a second. I'm taking row 2 and multiplying everything by -1/2. -1/2 times -2 will give me +1. -1/2 times 2 will give me -1. -1/2 times -2 will give me +1. We're still trying to find the first goal, right? Our first goal is we still want this to be a 1. Now I can see, if you don't remember, let me just write it down. Recall that when you're doing matrices, there's only 3 operations allowed. The first one is you can interchange rows. You can multiply any row by a non-zero number. And the third and last one is you are allowed to add them together. So those are the only 3 operations allowed when we're talking about matrices. So as you can see, if I want this one to become 1, I'm going to use the interchanging one. I'm going to take row 1 and row 2 and I'm going to interchange them. So that means row 2 is now going to become my first row. So here's my new row 1 and row 1 is now going to become row 2. So here is my new row 2. Now that this is a 1, your next goal is everything below has to be a 0. So now we want this to be a 0. So the way you get anything under to be a 0 is through the use of your first row. So, because we can multiply by 0, I cannot interchange it and get 0. I must use the addition one, right? So I have a +3. The only way to get a +3 to become 0 by adding something is to add -3. So that means we have to make this a -3. So we're going to take -3 and multiply it to row 1, because that's going to make it a -3, and then we're going to add it into row 2. So we end up with, we're not changing row 1, that one's done. There's nothing else we need to do there. We're changing row 2. So we're going to take -3 times 1, and we're going to add it into 3. So that's how we get the 0 we wanted. We're going to take -3, multiply it by -1, and add it into 5. So we end up with +a. We're going to take -3, multiply it by +1, and we're going to add it into 59. So that's how we end up with 56. Once you get 1 here, and everything below to be 0, keep working your diagonal. All your diagonals have to be 1, so that means my next goal is to make this a 1. Once you have a 0 here, you can no longer use row 1, because if you use it again, you're going to mess up the perfect 1 and the perfect 0 right there. So that means the only option I have here is to multiply by a non-zero number. What can we multiply a to make it a 1? Don't be afraid of fractions. We can multiply by a fraction. We're going to take 1/8 and multiply it into row 2. So I have 1, negative 1, and 1. So I have 0 times 1/8. It's still going to be 0. So that's why we don't use this one anymore. So we don't mess with our 0. 1/8 times 8, that's going to give us the one we're looking for. And 1/8 times 56 is going to give us 7. Once your diagonal is 1 and everything below is a 0, you are done applying Gaussian elimination process. And you're going to take this back and write it as a system of equations. So look, this is the placements of your x, y's, right? So we end up with 1x minus 1y is equal to 1. When you look at here, look, we have 0x's, we have 1y equals 7. So that's the nice thing about matrix and Gaussian elimination process. It helps you solve for the last variable. So this one's already solved for y. I can use this to be able to solve for x. So I'm going to replace y with 7, and I'm solving for x. So that's how I get x is equal to a. So the solution to the system will be the order pair 8, 7. Make sure you're able to apply matrices. The other one is Cramer's rule. So let's take the same system of equations. We're taking 3x plus 5y equals 59. Negative 2x plus 2y equals negative 2. And we're still solving for the system, but now we're going to apply a different method. We're going to apply Cramer's rule. So if we're applying Cramer's rules, I know x is equal to the determinant on x over the determinant of the system, and y is equal to the determinant of our y over the determinant of our system. So when you're working with Cramer's rule, you're just working with a bunch of determinants. So we're using the determinant of the system for both, so I'm going to start by solving the determinant of the system. The determinant of the system is the determinant of the coefficients of your x and y terms. So we are only looking at 3, negative 2, 5, and 2. So I'm looking at the x coefficients and the y coefficients. Oops. And we know how to find 2 by 2 determinants. We cross multiply. 3 times 2 is 6 minus cross multiply negative 2 times 5 is negative 10. Double negative becomes positive, so that's how we end up with 16. Now we have to find determinant on x and determinant on y. Determinant on x is going to be, you look at the determinant of your system, but because we're interested in determinant on x, you're going to change your x coefficients. So that means my y coefficients stay, but we're going to change whatever variable we're looking for. We're going to change the column of those coefficients into the numbers on the other side of your equal sign. So this is going to become 59 and negative 2. It's still a 2 by 2, so cross multiply. 59 times 2, we get 118, minus cross multiply negative 2 times 5 is still negative 10. So 118 plus 10 becomes 128. So now for determinant of y. Look back at your determinant of the system. Now we're interested in solving for y, so our y coefficients are the ones that are going to change. So that means our x coefficients stay, but our y ones now are going to become 59 and negative 2. Cross multiply, 3 times negative 2, we get with negative 6 minus negative 2 times 59, 118. They become positive, so negative 6 plus 118, we end up with positive 112. Now that we have all the determinants, now we're able to solve for our system. And if we did this correctly, it should match the solution we previously found. So x is equal to determinant on x, which is 128, over the determinant of the system, which is 16. 128 over 16 is equal to a. y is equal to the determinant of y, which is 112, we found it to be 112, over the determinant of the system, which we found it to be 16. 112 over 16 gives us 7. So in fact, the order pair is 8, 7, which matches what we previously found. So that's how you apply both matrices and Cramer's rule.